We're going to continue with the properties of logarithms. At this point, we know that exponents and logs are inverses, and we can change the one form to get to the other form. Today, what we're going to do is look at the other properties of logs, including the product property, the quotient, the power rule, the change of base rule, and we're going to finish up with doing some examples on those and looking at compounded interest formula. So to start with, we're going to look at the product of logs, and when it talks about the product rule, it's talking about the product of what the log is taking. And so the product of a log is equal to the sum of the logs. Or the log of a product is equal to the sum of the logs is what's happening here. And again, you think of a log as an exponent. And so when you have a product and you're thinking about exponents, when you multiply powers, you're actually adding the exponents, and that's how you can think about adding the logs. The second property is the quotient property, and the quotient property is where you in fact subtract the logs. It's just like when you have a power divided by a power, you actually subtract the exponents. And again, that's what's happening here. You can think about it in terms of exponents. Power rule. In fact, if you were to think about this in terms of exponents, it's like a to the m over a to the n is equal to a to the m minus n. That's the quotient rule for powers. And the one up above it was a to the m times a to the n is equal to a to the m plus n. Because of this addition and because of that subtraction, it's the same thing as what you saw on the other side. Power rule says that instead of having an exponent on top of the number, what you're doing is you're moving the exponent out front. It's just a way of simplifying logs as you go through and solve problems. Then what you're going to do is know the difference between a common and natural log. A common log is where it's always base 10. Always base 10. And you're going to see that they don't write base 10 all the time. It's kind of like the sign of x. They write it as S-I-N-X. It's not S-I-N-E. Or 1x, you write it as x. Same idea here. The common log is always base 10. If they leave it out, it's assumed that it's base 10. Natural log, that has its own way of writing it. It's lnx, and lnx is the same thing as log base e of x. It's called the natural log. Natural because it occurs in nature. It occurs in compound interest problems, growth problems, and so that's why it's called a natural logarithm. The other property that we're going to look at is the change of base property, and you're going to see that the change of base property is where your base is not a natural log, or it's not e or it's not 10, it's a different number, and when you have a different number, your calculator cannot calculate that. It doesn't have the function to calculate it. So you always have to change a base that's not e or 10 to a base that is e or 10, and this is how you do it. This right here is equal to the same thing. B can be equal to 10 here, or B can be equal to E here. So it doesn't matter which one you use, you're still going to, that ratio is still going to give you the same number. I'm going to go through and apply these properties now, so just have those handy, and we're going to do some expanding, some condensing, and then solving some equations. Let's start with, if you want to follow along in your book, I'm at number 4 and page number 820. 820 says you have the log base 3 of x over 5. And the directions are simple. It is only expand as much as possible. You only have one thing going on here. So the expansion is pretty easy. Instead of writing it as a quotient, you're going to separate that as a difference of logs. So that's going to look like this. When you have the log of a quotient, it's a difference of logs. But these things can get a little bit more complicated. You have in number 12, log base 8 of the cubed root xy to the 6th power. Now on this one, you don't want to deal with radicals. You want to get rid of the radical right away. So instead of that, you're going to look at rewriting it as this. And then you're going to do a combination of the steps. Now, I'm just for simplicity's sake, I'm going to be doing a couple things at once. The first thing I'm going to do is move that 1/3 out because that's going to clear this whole exponent of the problem. Notice it's 1/3 to the whole of the whole base. It's not just one of them, it's the whole base. So that's where I can move it out front. Then I'm going to be looking at expanding this, what's on the inside. To do that, I can do the log base 8 of x plus log base 8 of y to the 6th, which really the 6 comes out front. So I'm going to do two things at once there. First thing, log base 8 of x plus, and then I have log base 8 of y to the 6th, but that 6 goes in front, so I can rewrite it as that. Now, if that confuses you, just do another step and then move the 6 out in front in that one, the next step. Number 20. Number 20 is quite a bit longer, and that's going to be where we have something that looks really ugly here. Log base 10, x to the 4th, y to the 3rd root over z to the 1/2 power or square root. So at this point, again, you're going to want to think about how do I break that down in terms of terms. So I have a product here, and then I have a quotient. So I'm going to work on the product first, and then I'm going to subtract off the log. And I can do everything actually in one step here. So the first step is going to be to break down the first one. So it's going to be this term with the x to the 4th. The 4 goes out front. So I'm going to be 4 log base 10 of x. I'm moving the 4 out front, and I'm rewriting that log. And then it's going to be plus the next log. So what is the next log? The next log is going to be to the 1/3 power, which means 1/3 log of y. And then it's the quotient, so I have to subtract off the next one. Well, z, the square root of z is z to the 1/2. The 1/2 goes out front, 1/2 log of z. Again, I did a couple things at once when I did that, but I think you guys can follow. Let's go to the next one, which is 26. 26 says instead of expanding, we're going to condense it. So this says 4 log base 2 of x plus 5 log base 2 of y. Combine. It's the sum of logs. We can combine them into one log, so this becomes log base 2. It's the same base, so I can combine them. This is x to the 4th, right? Really, 4 comes out on top. It's an exponent. Times y to the 5th. So I do using the power rule as well as the product rule. Number 30. Number 30 says 2 log base 3 of x plus 3 log base 3 of y minus log base 3 of z. All right, so we have an addition and then we have a subtraction. This first one, again, log, all are log base 3, so I can combine them. Log base 3 of x squared times y to the 3rd. And then I have the subtraction, so that makes a quotient over z. Not too bad. Let's take a look at solving for x now. And so number 40 is a different direction altogether. Log base 6 of x plus log base 6 of x minus 1 is equal to 1. And the directions are solve for x. So first we expanded, then we condensed. Now we're solving for x. We have an equation. I want to combine it into one log and then use your exponential to change it into the log form. So let's go ahead and combine it. Log base 6 of x times x minus 1 equals 1. Then I get rid of the log so I can solve. I end up with 6 to the 1 is equal to x times x minus 1. This is where it's the base to the exponent equals the number. Switching it in forms. Now I want to set it equal to 0, so it becomes x squared minus x minus 6, subtracting x and distributing. I then want a factor, which is going to be x and x minus 3 plus 2. So x equals negative 3, positive 3, or negative 2. Now, when you do this, the question is, can you have a negative x here? Can your x be negative? And so I guess I'd like to think about that a little bit in terms of, can that x be negative when you substitute it in? If I were to take, for example, this is just thinking off to the side, if I have log base 6 of negative 2 equals my box, some sort of number, because I want to know if I can get a number. If I change that in forms, I can get 6 to the box is equal to negative 2. Can 6 to any exponent equal a negative number? That answer is no. It's got to be more than 0. So actually, this negative 2 is a problem when I'm trying to figure out what that exponent is. Because that negative 2 has to be positive, this one right here gets eliminated because you cannot have a negative in for that number. Number 48. This one's a little more interesting. Log base 2 of, I'm just going to rewrite this as x to the 1/2 plus log base 2 of 6x plus 5 to the 1/2 equals 1. The question here is, how do you solve for x again? You have logs with the same bases. You can combine them into one. I changed the radicals into rational exponents, so that becomes log base 2 x to the 1/2 times 6x plus 5 to the 1/2 equals 1. I now change the form again, so it becomes 2 to the first power equals. Now, I'm going to look at this, and I'm going to try to make sense of that. I can see they're both to the 1/2. So my question is, how can I simplify that and make it a little bit better? Well, I can do that by a power rule that says that that whole thing the power rule says that if you have a power, you're going to be doing this whole thing under the power. So if this were squared, you would be taking x squared and you'd be taking this squared. If it's 1/2, it's the same principle of what's above it. That's important because now I can take each side to the squared power, square both sides, and so that becomes 4 equals x. I'll just distribute through 6x squared plus 5x. Then I want to solve for x, 6x squared plus 5x minus 4. That I want to try to factor at this point. Whenever I have a number with factors in front, I personally always break it down to 3x and 2x first. I break down in factors first because a lot of times it just so happens that I see that a lot more frequent than the other way, just by doing a lot of these. So I start with that, and then I have 4, and it's negative, so I'm looking for a difference such that it's equal to 5, and so I'm looking at 2 and 2 or 4 and 1. 4 and 1 looks like it'll give me a difference, so if I put a 4 here, it'd be 8. 1 here would be 3, so there's your difference of 5. I just have to put the negatives in the right spot. Plus 4 minus 1, always check. Positive 8 minus 3 gives you 5x. So at this point, you're going to see by setting those both equal to 0, 3x plus 4 equals 0, 2x minus 1 equals 0. Your x is going to equal a negative 4 over 3. And in the second one, your x is going to equal 1/2. And then again, you're checking to see if these things work in your equation. Because you squared them, you really should see if those work or not to see if you get your answer. But the negative 4/3 is a problem because you're taking the square root of a negative 4/3 there. So that one I don't like. I'm going to cross that off as an invalid answer. And then I'll stick with the 1/2. And again, you can test that and hopefully that would work. All right, a couple more problems on the change of base law. I'd like to do problem number 12 and let's say 16. 12 and 16 on A32. And the first one is solved for both using a calculator. 9 to the power of 7 minus 3x is equal to 5. And your question is, how do you solve for x? To solve for an exponent, you have to put in log form, and that should help you solve it. So I want to do, I'll just do the common, log base 9 of 5 is equal to 7 minus 3x. And then what I want to do is solve for that x. I'm going to add 3x to both sides, subtract that. So 3x equals 7 minus log base 9 of 5. And then I want to divide both sides by 3. Now, that you have to be a little bit careful with when you plug that in your calculator. So let's go ahead and try to do that. This is a problem because you cannot use the base 9 in your calculator. So we want to change that to either the common log or the natural log in your calculator to compute. So to do so, I'd like to put parentheses around the numerator. 7 minus common log 5 divided by common log 9, end of parenthesis, end of parenthesis. So your parentheses really have to be, you have to be really careful with parentheses here. You really have to put that in parentheses, and they're going to prompt you probably with that in parentheses. So on your calculator, you have to do it around the whole numerator and finish that log out. And that's where mistakes will occur on your calculator. So on here, you're going to see that you have that numerator finished out, and then you're going to divide it by we have a malfunction on here. Well, that's okay. We'll start over. Okay, divided by 3, and you're going to see that you get 2.08. Now, I just want to show you one more thing. When I hit second enter, I can get the same exact answer just by doing the natural log. Look and see what you have here. Natural log ln of 5 and ln of 9. And notice ln is paired with the e, common log is paired with the 10. That should make sense there on your calculator. And you'll see if I change those, you'll still get the same answer. So 2.09. All right, I'm going to hold off on the compound interest, and we'll talk about that tomorrow with some other story problems. Your homework is going to be the second page of the packet, front side and back side.